Okay, I think my battery died. So, here are some problems. Is the relationship an inverse variation? And so you see 6 problems. And what we need to do is decide if it's an inverse variation. If it is, then we will be able to find k, or we will be able to write it as xy equals k. To find k, there's a couple of different ways, but k has to be the same for each pair of points, for each x and y. We have to make sure we have the same k. Probably multiplying is the easiest, but I'll show you both. So for number 1, to find k, or to see if they would make an inverse variation, we have to write them each in that format. So remember, it's y equals k over x. So if we were to write it, we would have 30 equals k over 1. And then we would write 15 equals k over 2. And 10 equals k over 3. All I've done is I've rewritten these points in the inverse proportion equation. Then you would solve it for k by multiplying by the denominator. So times 1, so k would be 30. Times 2, k would be 15. And times 3, 15 times 2 is 30. And times 3, 10 times 3 is 30. So k is equal to 30. The other way that you could do it is you could just multiply x times y. So 1 times 30 is 30, 2 times 15 is 30, and 3 times 10 is 30. Since they all have a consistent k, then the answer is yes, this is an inverse variation relationship. Alright, so number 2, the easiest way to do it is to multiply x times y. So 1 times 5 is 5, 2 times 10 is 20, and 30. Now, although there is a relationship, it's going to be linear, and it's not an inverse variation relationship. So the answer is no, because they do not have a constant k. Number 3, we don't have a table at all. We have an equation.
Miss Kellogg, got one vote, please. Miss Kellogg.
So the question is, can we rewrite it to look like this? If we divide by 2 on both sides, we get xy equals 14. And then we could divide by x, and we get y equals 14 over x. So in either case, right here, the answer is yes. This is an inverse relationship, an inverse variation relationship, because you can rewrite it in this format. Number 4, we have a table again. So when we multiply across, negative 12 times 24, 1 times negative 2, 8 times negative 16. And you can see quickly that this answer is going to be no. Another thing that you need to...
Mr. Jacobs, got 112, please. Mr. Jacobs.
Another thing that you could look at to kind of see is an inverse variation means as one value increases, the other decreases. So that means if we were to go from negative 12 to 1, then we would, so this is, well, okay, yes. This one is going from negative 12 to 1, it's increasing, and this one's decreasing, but it's not at the same rate as over here. See, this is getting bigger and this is getting smaller. From here to here, from 1 to 8 and negative 2 to negative 16, these did get smaller and these did get bigger, but when you multiply it across, you see that you do not have a constant k. So you just want to pay attention to that. Number 5, if you multiply across, 3 times 3, 9 times 1, 18 times 0.5. So you would see that each time you would get 9, so the answer is yes. And then down here, number 6, we want to rewrite the equation to look like this. And because I have this plus sign right here, that means we cannot, so the answer would be no. So write an inverse variation equation. What we're going to do is we're going to find k, and they're going to rewrite it using the y equals k over x. In this first example, I gave you an x value and a y value. To find k, you multiply x times y. So we multiply 0.5 times negative 12, and we found that k is equal to negative 6. Once you find k, then you rewrite it as y equals k over x. Okay, so number 2, I'm going to multiply my x and my y to get k. 10 times 1/2 is 5, so k is equal to 5. Once you find k, now we can write a inverse variation equation using y equals k over x. So you try number 3, pause the video, you try number 3, and then press play. So check your work and see if you got y equals 2 over x. And if you did, then you got that one correct. To find a missing value in an inverse variation, you're going to use what's called the product rule. And the product rule in an inverse variation states that if you have 2 ordered pairs, then the product of x1 and y1 is going to equal the product of x2 times y2. And that is the reason that works is because k is a constant for every single point on that inverse variation. So no matter what point you have, if you multiply the x-coordinate times the y-coordinate, then you're always going to get the constant k. Therefore, you set them equal to each other and we can find the missing value. So let me show you what I'm talking about. Over here I'm missing a y, but I'm going to use the product rule. I'm going to multiply 5 times y, because you multiply x1 times y1, and that equals 3 times 10, which is 30. Divide both sides by 5, and you can see that y equals 6. Okay? And then from here, I've given you y1, x1 and y1, and x2 and y2 is missing. So again, I'm going to multiply. 2 times negative 6 is negative 12. And negative 4 times question mark is going to be negative 4y. Divide both sides by negative 4, and y equals 3. So you try number 3. This is 18.5, x, and 3. You try number 3, press pause, and then press play when you're ready to see. And this x value is 3. So if you got 3, then that means you got it correct. And now we're going to move into the applications of these inverse variation problems. Ooh, okay, here we go. Time is inversely proportional to speed when traveling. So that should make sense to you. Time and speed. If you drive faster, then your time is inversely proportional to speed. Okay, so that's what it is. If your speed increases, if you drive faster, if your speed increases, then your time is going to decrease. If you drive slower, if your speed decreases, then your time is going to increase because it's going to take you longer to get there. To travel 350 miles, use the equation xy equals 352. We have 2 things. We have to determine a reasonable domain and make a table of values. We know that according to the inverse variation function, the domain is all reals with the exception of our asymptote. So with this would be, since we're not shifting, it would just be where x is 0. But a reasonable domain for speed and distance, we're trying to go 350 miles, so speed and time, to go a distance of 350 miles, we have to use a very specific domain. So let's be realistic. That's why it's asking for a reasonable domain. We know the domain could be anything positive. And I guess the thing is, you need to figure out, is the domain your speed or is the domain your time? Which one has to be the domain? Which one is going to be the independent variable? Is time going to be the independent variable, the time it takes you to travel somewhere, or is the speed that you're traveling going to be the independent variable? And the independent variable is going to be the speed, because that's what you can control, that is going to be your X value. That's the one that you can change how fast you're going, and the time it takes you to get there depends on your speed. So we're talking about a domain, we're talking about the speed. So of course we need to have a positive speed. And let's be realistic, if we're talking about traveling in a car, we're not talking about 1, 2, 3, 4 miles per hour. We're not even really talking, if we're going 350, we're not talking about 20 miles an hour or 30 miles an hour. We'll probably need to stay above the range of positive, so greater than 40. So something that is X should be greater than or equal to 40, and probably, I think, maybe 70, because anything above 70 probably is going to be speeding. But 40 to 70, I think, is a good range. Some people might say 30 to 60 might be a better range, but I just know when you're on, like, the interstate, you'll see signs that'll say speed limit 70 and minimum is 40. So this would be a reasonable domain for speed. And then it says we need to make a table of values for our function. So let's say we were going to do 40, 50, 60, and 70. Because I'm choosing to use these values, I have to plug them into the X, and then I'm going to solve for the Y value. So if we did 350 at 40 miles an hour, then what I did was I put in 40y equals 350, and then I solved. 350 divided by 40, it's going to take us 8 hours and 45 minutes, or 8 and 3/4 of an hour time to get there, to do 350 miles. 350 miles at 50 miles an hour is going to take us 7 hours to get there. 350 divided by 60 miles an hour is going to take us 5.83 repeating hours. And then 350 divided by 70 miles per hour is going to take us 5 hours to get there. So that is a real-life application problem, and we had to find a reasonable domain, which is going to obviously be some high numbers, not 1s, 2s, and 3s, and nothing negative. Alright, real world number 2. Boyle's law states the pressure of gas X, varies inversely as the volume of the gas. Why? The volume inside is 400 inches cubed, and the pressure is 25 psi. What is the pressure when the volume is 125 inches cubed? So we are looking for a missing value in this one. We're looking for the missing pressure. And it told us that the pressure is X and the volume is Y. So in this first one, they give us that 25 is our X and 400 is our Y. And then they tell us the volume is 125. So we're missing our X value. We're missing the pressure. Since I'm missing a value, I'm going to use the product rule. So I'm going to multiply 25 times 400, and I get 10,000 equals 125x. I have to divide the size by x, and I get 80 pressure, 80 psi. And that should make sense, because as my volume went down from 400 to 125, my volume decreased. From 25 psi to 80 psi, my psi increased. So that should make sense.